area between two curves. Suppose that we have the function f of x and the function g of x, and we need to find the area enclosed by the function f of x and g of x over interval from x equal to 0 up to 1. From the graph, it seems that the function f of x is above the function g of x all over the interval from 0 to 1. That area which we need to find, we can think first, how can we approximate that area? If I need to approximate that area, we learned too many ways to find approximation of that area. If I said that I'm going to make rectangles between f of x and g of x, so the height of this rectangle will be y2 minus y1. y2 minus y1, or will be f of x minus g of x at any point inside that interval. So if I said that this is the height between the function f of x and g of x, that height h equals f of x minus g of x. Or we can say that the height will be equal the upper function minus the lower function. So I have two functions. The first function is f of x. It's always above g of x over the given interval from 0 to 1. So we can conclude that the height all over that interval will be equal the upper function minus the lower function. We learned also how can we approximate that area using rectangles. We know that the width of that rectangle will be equal to delta x. So I can say that the area enclosed by the two curves, will be equal the integral from a to b, from point A, the initial point or the starting point, up to the end point B, for the function f of x minus g of x dx. Someone can ask, I can use that equation to find area. I can use that integral to find that area if the area is above the x-axis. But what I can do if that area is below or above and below the x-axis? We can say that if I need to find the same area, or if I need to find the area between the same two curves at x equal 2 up to x equal 4, how can we find that area? By the same way, I can approximate the area first. To approximate the area first, I will graph a small rectangle. That rectangle with height equal f of x minus g of x, f of x minus g of x, and also with width equal to delta x. So I can conclude that if the area is enclosed by two curves, the first curve is above the second curve all over the interval, which I'm going to use to approximate or to find the area at that interval. I'm going to make the areas equal the integral from a to b, the initial or the starting point, to the end point, for the upper minus the lower curve. And this will be our first case, and let's take some examples for that. For example, if we said that what's the area of the region between the graph of f of x, which is equal to x squared plus 5x, and g of x, which is equal to minus x squared minus 6x plus 4, from x equal to negative 4 to x equal to 0. If you look to the graph for both functions, g of x and f of x, you will notice that the function g is red function and the function f is a blue function. He wants to find the area enclosed by both functions at the interval x equal to negative 4 up to x equal 0. This is the first case, which the question will decide or will give us the area or the interval the starting point and the end point of the interval which I need to find the area for. So if you look from x equal to -4 up to x equal 0, you will notice that function g of x is above the function f of x all over that interval. The function g of x is above the function f of x all over that interval, and the area totally enclosed by both curves at that interval. So directly we can say that the area will be equal the integral from -4 up to 0 for g of x minus f of x dx. So the area will be equal, let's substitute g of x by -x square. Area should be equal the integral from -4 up to 0 for -x square minus 6x plus 4, and here we have to put negative sign, but after you put the negative sign, don't forget to make a bracket, because the negative sign for all the function f of x, not for the first term only, minus the function 2x squared plus 5x dx. Then you can load that integral directly to your calculator to find the integration from -4 to 0, and it will be equal, I think it will be equal to 40. It will be equal to 40. Directly use your calculator. But what will happen if you didn't find the solution after you make the integral using your calculator? You have to review some important points. The first point, which is have to be reviewed if you didn't find your solution, the negative sign. After you put the negative sign, don't forget to make the bracket. This is the first one. The second one, if you have sine or cosine function, like some questions, inshallah we will take it later, you have to review your calculator if it's on degree mode or radian mode. Okay, one more question about how can we find the area. What is the area of the region bounded by the graph of f of x, which is equal 4, and g of x, which is equal e to the power x over 5, and x equal to 0? On that question he gave us three main equations: the function f of x, and the function g of x, and an equation of a straight line x equal to 0. We should know that the area enclosed by three curves. The area enclosed by three curves. The first curve, which is f of x equal to 4, is a horizontal line, passes through y equal 4. This is the function f. And the function g of x, which is equal e to the power x divided by 5. E to the power x divided by 5, and this is the graph of the function. And the third one is an equation for a straight line x equal to 0, and we know that x equal to 0 is a vertical line. X equal to 0, the vertical line, or it will be y-axis. So we need to find the area enclosed by these three curves. The area here enclosed by the three curves. We can find that area using two ways. Today, or on that class, we are going to find it by using the integral for x, or with respect to x. So I can say that the area which is enclosed by the graph of the function f of x and g of x is enclosed for x equal to 0 up to 3. The area, or the region which we need to find its area, is enclosed by x equal to 0 up to 3 only. the first point x equal to 0, and I think this already given. The second point is x equal to 3 with the intersection point between f and g. So how can we find that area now? We can notice that there is no intersection point inside the shaded area, so directly we can find the area by integral from 0 up to 3, from 0 up to 3 for the function f of x, which is 4, minus the function g of x, which is e to the power x over 5 dx. And directly you can use your calculator to do that integration. You can make the integral by the calculator, the integration of 4 minus e to the power x, e to the power x, alpha e to the power x divided by 5 from 0 up to 3, but the calculator will give you a decimal value 8.18, 8.18, so that integral will be equal to 8.18, but none of the given solutions is 8.18, so you can simplify the first and the second and the third until you reach the correct answer. So put the first one for len 20 minus 4e over len 20 plus 1 plus e over 5, and so on until you reach the correct answer. Okay.